I'd like to pass the floor to Mr. Eugene Lam from Netrust to share more on the importance of SSL certifications for web security. Over to you, Eugene.
Thank you for this session. I think I'll share some of the concepts of what SSL certification is about, some of the concepts of what PKI is about, and of course share a little bit about myself and my company. So maybe can I have the next slide, please? So who is Netrust? Before I share or before you listen to any conversation or any talk, usually there is a credential sharing, right? So this is our credential. I think Netrust has been quite well known in the SSL industry or the PKI industry because we have been here for 23 years. We are the first public certification authority since 1997, and we remain the only commercial accredited CA. There are many CAs within Singapore that came and went, but we are the only one that is commercially accredited. And over the years, beyond just Singapore, we also expanded our trust program to Microsoft Root Trust. So if you go open your Internet Explorer and you search the certificate, trusted certificate root store, you will see a Netrust certificate. And if you do a digital signing using a Netrust certificate, you will see that there will be a green tick in the Adobe Trust List, AATL. Okay, can I have the next slide, please? Beyond just doing PKI or CA, we have also expanded our offering. We do crypto identity security solutions, infrastructure security. So in a few years back, Netrust acquired a company, Titan Security, which deals with infrastructure security. So the entire stack is now added in, the firewall, IDS, IPS, and stuff like that. There's application security, cyber vigilance, and support and maintenance. So these are the whole buffet of solutions that we provide. Okay, so enough about Netrust. Can I have the next slide, please? So I think today we are here to talk about SSL. To get everybody on the same page, I just want to share the definition of what SSL is and how is it being used. So SSL stands for Secure Socket Layer. So now I think today's term is always often referred to as a product, but the actual term of SSL stands for Secure Socket Layer. It used to be SSL, now people call it TLS. It is used to, it is a protocol actually that's used to encrypt the data that's being sent over the internet. There are several items within TLS and SSL. We're not going to go into the cryptographic functions of that, but there is something known as a key and there's something known as a digital ID. So the cryptographic key is something that we go into more details. So this couple of things are then merged together to create something known as a secure communication pipe. But before we go into all this, let's look at what is a secure communication pipe. Oh, sorry, we will look at cryptographic key pairs first before secure communication pipe. So I have a couple of examples here on what is a cryptographic key pair. We have a couple of key pairs that are used quite widely in the internet. One is known as a symmetric encryption. The other is known as asymmetric encryption. So what is a symmetric encryption? In the event that I want to encrypt a data and I want someone to decrypt the data, typically I will encrypt the data with a key. So let's say my key is 1234. In the event that someone wants to decrypt the data, the person will need to enter the key of 1234 or decrypt it with a key of 1234. Okay, the most I won't say the easiest example, but a similar example will be like if you want to send something like WinZip, for example, you send it to someone else, you send it to a third party, you will often ask, and you want to protect it, you will type a password, you create a password archive and send it over. He will use the same password to unlock the WinZip. That is symmetric encryption. But how do you then send the key over? You will have to go through another third-party channel. Maybe you call the person or you email the person or something like that. So we have to communicate the password or the key over to another person. Okay, asymmetric encryption. There's a couple of examples that I can share. The first example deals with like postal system. So like in Singapore's context, I won't say everybody can know my address. I'm not going to share it here, but address itself is not confidential per se. Like you can have addresses, but if you want to send me a mail, you are quite certain that I'm the only one that can read my mail because I have the key to my mailbox. So that is the concept of asymmetric encryption. I don't use my address to decrypt the message. I don't use my address. I don't go to my mailbox and shout my address. Doesn't work like that. I just go there, I present a key, and that key is used to decrypt the message or open up the message. Okay. Another method of which I felt that asymmetric encryption is probably in use is in the army. So when a hostile force or a party meets another party, there is a key exchange. So this person will shout, let's say the code word of the day is apple strudel, for example. So the first person will shout the public, the person who wants to challenge will shout the public, the key phrase. He will shout apple. And then the other person is not supposed to reply with apple. If the other person replies with apple, then he will get shot. Or he replies with something else, he will get shot. The other person is supposed to reply strudel. So it's asymmetric in nature. So you're not supposed to use the same key. So this requires sort of dissemination of keys beforehand, before we actually do the challenge or the authentication. Okay. So these are the two methods of using cryptographic key pair. Can we have the next slide, please? So in the PKI, there's a couple of things. First is encryption of key pairs and digital certificate. These two things sort of make up a system known as a PKI or public key infrastructure. There's many other things within the PKI, but we're just going to focus on this couple of things. The main use of a PKI is really a couple of functions. The first one is to encrypt data. So you encrypt things so that the party cannot read or cannot see what information is being sent. And the second one is for authentication. So the first one, encryption, deals with the key pair. The second one deals with identification, which is the authentication. So it confirms that the party is really who they say they are. And that information is actually held within the digital certificate. So these two items, of course, there are many other items, but these two items are the items that we will sort of focus on today. I'll share a little bit more detail in the following slide on other components of PKI. Can we go to the next slide? So we have the public-private key pair, the postal system and the WinZip system that I've shared just now. We have a digital ID. So if you open up a digital certificate or you open up any files on your computer that is .cer, you open up, you will see a lot of information, or you will see something that that may look alien to you. If you notice within that pop-up that appears, the certificate information or the digital certificate will include something known as a digital ID. There will be a CN equals to something within there. We don't really have to worry about that, but that sort of identifies who this certificate is for. If I just give a third party, a random person, a private public key pair, he or she will not know who this key belongs to. So typically the key pair is being sent within the certificate. So the public key is sent within the certificate so that there is an identity that is binds to the key. So that is the main purpose of the digital certificate. The digital certificate also allows you to do a few things. So it will tell you what the certificate is supposed to be used for, because there's a lot of usage for the digital certificate. You can use it for encryption. You can use it for like identification. You can use it. There is something known as a key usage that's within the digital certificate. And that key usage can be used to sort of lock down what is the purpose of this digital certificate. Okay. And digital certificates are issued by trusted third party like Netrust. So that term is known as a certificate authority. So certificate authorities like Netrust or Entrust, we issue digital certificates. So we do validation of users first. So let's say, for example, Eugene Lam, I want to apply a digital certificate. I will go to Netrust and I say, okay, can you issue me a digital certificate so that when I want to do a transaction with Toby, I can identify myself. So that is the simplest way of using a digital certificate. I want to sign my email, for example. Then Netrust will then say, okay, great, you want to buy a digital ID from us. Can you provide me with a government issued ID? Then I will go to Netrust office. I will give my digital ID to Netrust. Netrust will then do a face-to-face verification with the digital ID and then issue a certificate to me as an individual. Okay. That very similar concept can be done for organizations as well, can be done for websites as well. That is the main crux of why public certification authority exists. It is a trusted third party, so that we can issue IDs to members of the public to perform digital transaction. Okay, that's a CA. There is also chain of trust. Chain of trust we will go into a little bit of details later, and digital signatures, processes, policies, and procedures. We are not going to go into the last 2 points. We're just going to focus on the next 2 points, CA and chain of trust. Can I have the next slide, please? Okay, so everybody can sort of be a CA. I can set up a shop tomorrow and be a CA, but without third-party accreditation, nobody is going to trust the CA. So who do all these CA authorities, or is there a governing authority for CA? And the answer is yes. There is this authority called CAB, especially for SSL. So there is a CA browser forum that so all the big boys are there. So for example, Microsoft, Google, Mozilla, the browser forums are there. They sort of set the standards that, hey, let's not issue certificates for like 10 years, for example. So they will come up with policies and procedures like that. And in order for us to be a trusted authority, we will need to then follow the process and rules defined by the CAB forum and go through annual audits. So the gold standard is actually called Web Trust. So there are also third party, or there are also government related standards. Like for example, IMDA also issues a standard of which we have to be compliant to. So we are audited against that standard in order for us to be a digital certificate provider or a CA. Okay. Next slide, please. There is a concept known as chain of trust as well. So when organizations join trusted programs, they usually don't trust me. For example, they don't trust Eugene Lam. They will trust the root, which is Netrust. So Netrust issues a root certificate, and that root certificate is then being placed in all the trust stores, of which the root certificate usually don't sign my certificate directly. So the root certificate will issue something known as an intermediate root certificate. So you will issue maybe a 5 years validity intermediate root certificate, of which this intermediate root certificate, root CA, will then sign on the end entity certificate known as the SSL. So in this case, it is possible for the root to be many years, 20 years, 30 years. I think typically it's about 20 years. So you have a very long, because to get into the root program is very difficult and you won't want to change that often. So how CAs mitigate the risk is issuing intermediate root CA. So in the unlikely event that there's a compromise or there's a need to change standards, they won't change the root per se. They will change the intermediate root CA, so that it is operationally, it makes more sense. Okay. It is also possible to lock different SSL certificates to different root, so you can control it by the root. But typically, people don't remember who the root is. The root is usually sent together with the authentication request, so you don't really need to care who the root is. Intermediate root is. As long as you trust the root certificate, you will trust the intermediate root certificate, and you will trust the SSL certificate if the system is configured properly. It's designed to be like that. So you should not, in most cases, you should not implement a system where the root certificate you will have to define, and the intermediate root you will have to define, and then the SSL cert you have to define. That will be quite painful because if, let's say, you need to authenticate 10,000 users, you will have 10,000 different entries. So typically how a system authenticates itself is through the root. And since I trust the root, I will trust any intermediate certificate that is being sent, and then any SSL that is being sent, I will also trust it if it's validated against the domain. Okay, so this is how organizations usually do their chain of trust. Okay, the most common question I get when I talk to non-IT people, or when I tell people, hey, I sell SSL certificates, they will ask me, what is the difference? Why your certificate so so expensive? So they will use the word expensive, right? I mean, it's relative. If you compare to DV certificates, there's a few levels of validation. There's DV certificate, there's OV certificate, and there's EV certificate. Okay, a lot of times we are being compared, or organizations are being compared to the DV certificate, or something that a lot of people know, because DV certificate just means that you domain validated, you have control over the domain. So how this works practically is this. Let's say I want to buy a DV certificate from a third-party provider. All I need to do is, let's say I want, let's say netrust.net, right? I need to host a file, netrust.net/confirm.txt. In the netrust.net confirm.txt, I will input characters that the CA asked me to, maybe a hex 8 characters hex decimal, of which they will then use through their software access and confirm that I have access to the domain. So because I can upload the file, I have control over this domain. So this just proves that I have control over the domain. They will issue me a digital certificate. That's DV certificate. That's the most basic level of control. And that's that. But let's say we go back to the example of netrust.net. How do I then know that this is belongs to Netrust Private Limited? Because there is no confirmation on the owner of the domain. It's just which organization owns the domain. The first DV just proves that someone is able to control or upload something into the domain. It doesn't prove that netrust.net owns the domain. That's where OV certificate comes in. OV certificate validates the owner of the website. So there's additional validation that's being done. One of the validation that's being done will be to really call up the organization to make sure that this organization really owns this domain and stuff like that. And additional validation is also done in EV. So in OV and EV, there are additional validations such as calling up of finding a publicly available line and doing a public verification that this person really owns the domain. So OV and EV provides a greater, provides a greater level of trust in the event that, let's say we want to do business with Netrust, right? And we go to netrust.net. We are sure that this netrust.net belongs to Netrust Private Limited. So when I do my payment, when I make my payment, I'm sure that I'm paying to Netrust Private Limited because it appears in the certificate. Okay. The difference between DV, OV, and EV. Can we go to the next slide, please? I think previously there was this very strong justification for EV because you don't even need to recognize the domain. You don't even need to see that it's netrust.net. In the browser itself, it will say that the company name is actually being shown. And this, because I do this for a living, when I do my digital transaction, especially with the banks, I really, really appreciate this because I don't have to care whether this is like DBS or UOB or OCBC or whatever. There will be a name that is there owned by DBS Limited, for example. So if you do a certain business and you want to buy a certificate, I highly encourage you to minimally get an OV certificate. If you can get an EV certificate, it's great. If you look at the trend-wise, most of the phishing attack happens at the DV level. There is like no, according to the report, there is no attacks that happen on the EV level because that really requires quite a fair bit of verification first before you can issue an EV certificate. Okay. Yeah, next slide. I went through this in the panel discussion earlier on why is there a need for SSL. I think SSL, if you are hosting a public-facing website, it is definitely important to host SSL if you want your website to be searchable via Google. It creates also a safe experience. Imagine we save on SSL and we want to, and users come and you encourage them to click and bypass the security warning. It is very difficult for a user to then differentiate between your website or a phishing website because the connection is not secure. So I think getting a public trusted SSL is definitely important if you serve public users or even if you have internal users as well. If your internal users are not tech savvy, then I would highly encourage you to get a public facing SSL certificate as well. Okay. Can I get the next slide, please? In terms of why SSL is important, SSL not just identifies, authenticates the user. So a lot of time SSL is, when people say, oh, I want to buy SSL, there is usually a domain and the domain sort of authenticates, prove yourself to the user. But SSL also does a few things. It ensures that because traffic usually is being sent via the internet, it ensures that your data is not sent in the clear. So it ensures a couple of things. It ensures that there is encryption, so your data is kept private. Especially if you need to send sensitive data, then SSL is highly encouraged. And there is no way that someone can modify the data when it's being sent. So let's say I want to send my name and let's say I win a lucky draw, right? I want to send my name and I send my my phone number. Someone cannot change the phone number and claim my lucky draw. Okay. Can I have a next slide, please? Some of the use cases on why SSL is needed. I think the more prominent one is like online credit card or payment transactions. If the website doesn't have a minimum SSL, there is no way I'm going to enter my credit card details. That's just, or even if there is a login page, or maybe file transfer or applications like cloud or mobile applications, right? If there's no SSL involved, anything that requires anything that requires me to send anything. So if it's not just one-way traffic where I just go and browse and just get static information, right? If it's anything that is two-way, I will definitely want to have a SSL. Okay, so that is the current use case. Can I have the next slide, please? I want to share a little bit more on the types of different SSL. The basic form of SSL is known as a standard SSL, where you can just host a website and it's OV validated. That's the one that we have. There is also an EV validated, where there's additional validation that is being done before we can issue a certificate. There's Advantage SSL, where you can host multiple websites on the same using the same SSL. So for example, if you have www, like for Netrust, we have www.netrust.net. We have other domains like nsisg.netrust.net. We can use Advantage. If we have more, we can use multi-domain SSL UC, or we can also use wildcard. Wildcard means it's a star.netrust.net. So anything that is netrust.net, we can trust this. Okay. There is also other things such as private SSL. Private SSL, if I want to host just for internal consumption, I don't need a publicly trusted. This is likely due to price or price reason or security concerns, where you don't want to use a publicly trusted. So you want to lock down to a specific CA provider, then that's where you will use a private SSL. There's other forms of different certificates that are not SSL per se. They are just different certificates. You have qualified and code signing, document signing. This deals with signing. So the bottom, a lot of the certificates below deals with signing. You have qualified certificates deal with EIDAS standards. We have code signing. So if you don't, if your organization is a provider of a software and you want to compile and you want to publish, you will need a code signing. And if the code signing is not properly configured, you will get some prompting on Windows. Your users will get some prompting on Windows that this is not trusted. So that is something that you will need to purchase a code signing certificate to before you issue. Document signing as well. So when you want to sign on documents, you can use digital IDs certificate to sign. In the case where previous example where I went to Netrust and buy a certificate over the counter, that's usually used for document signing. Email encryption and signing as mine. So if you want to send secure email, you can use that. And there's other things such as VMC and device certificate. I won't go into a lot of details of that, but there are many forms of digital IDs or digital certificates that a provider provides. I think if you have any questions on what type you should get, we get a lot of that question. It's okay, you don't have to remember. You just have to contact outside. Yeah. Okay. Next. But the digital ID is just really just one piece, right? If we say that, we want to embark on the digital ID, then there are really a lot of things that goes beyond just the certificate or the SSL. There are policies that controls it, like who can do what. There are provisioning. How do you securely provision? In the event that there's one certificate, it's fine. But let's say your organization have hundreds of certificates. It's very difficult to use an Excel file to slowly manually track. You need a platform, you need a way to discover where are all the certificates. You need to monitor whether the certificates are going to be expired or not. There's a lot of logistics that comes together with it. There is the lifecycle management of the certificate. And is there reports? Let's say the bosses want to know, hey, you buy 100 certificates. Do we really use 100 certificates come the renewal time? These are some questions that users will or management will want to know. They won't want to know how it's being done, but they want to know like the usage, whether are we getting value for money. I mean, these are some of the questions I ask internally when we do our renewals. So can I get next slide? So what Netrust does is Netrust has this portal called ECMS. Netrust portal allows management of the certificates in a very convenient manner. You can also do API integrations. You can integrate with third-party products. And certificate management, you can also delegate to sub-admins. So when you have a certificate management portal, it makes the management of the certificate, the life of the management of certificate much easier because everything is done within the portal. So if you want to monitor, hey, we get this notification. For me, I get this notification, the third point, right? Convenient expiry notification, right? In the event that some of my certificates are going to expire, the portal actually sends me an email to tell me, hey, this is going to expire. Like, can you please go and renew the certificate? So I will then forward this to my operations team to ask them, hey, are we renewing these certificates? Like, do we still need to renew? Like, is the service migrated? Like, are we still using this certificate and stuff like that? So this helps me check on my team to make sure that the cost is being fully utilized when we provision for stuff. Okay. The last slide that I have is a summary slide. I think SSL as a whole provides a few things. It provides the data encryption piece, which I have shared about using the keys. It provides data integrity as well, because when your data is being encrypted, nobody can then edit the data. So if the data is in the clear, the lucky draw example, then if the data is in the clear, then potentially people can edit the data, and the recipient will never know that the data is being edited. It also provides authentication. The key itself is useless. So, I mean, the key itself not is useless. The key itself, you don't identify who owns the key. That's where digital certificates comes in. There is a metadata, or there are information on who owns the key that is being placed into the digital ID or digital certificate. So the authentication part authenticates not just yourself, but potentially you can use the same certificate to authenticate when the client buy. So SSL is usually server authenticating to the mass public. So if I go to netrust.net, and netrust.net presents to me an SSL, Netrust authenticates itself to me as a customer. But it is possible for me to use a two-way SSL where I also buy a certificate. So when I log in, I will need to present my digital ID to Netrust. So it is possible to do a two-way authentication using SSL as well. So but it's not covered today. It's just a very cool concept that SSL can be used not just for one-way authentication, but two-way authentication. Okay. SSL also provides different level of validation. You can use the DV, where you can go to third-party providers. You can get even free DV certificates. DV certificates are not expensive. It provides a very minimum level of to ensure that this domain is secure and is trusted by for members of public. But it does not tell you who owns the domain. So like OV and EV allows you to then do that. So that's the main difference between DV certificate and OV and EV. If organization is worth its salt and is serious in doing online business, then I will highly encourage the organization to minimally get an OV certificate, so that at least the company name is within the certificate. Okay. If the organization can spend more money to get EV for better brand protection, then that's better. Okay. Certificates also need to be managed. So once I hope you are convinced on the need to use certificates. If you're convinced, then other things such as management of it, the automation of it, and the discovery of the certificates becomes more rampant, because once certificates are being deployed in the environment, which I'm very sure they are, once they are being deployed in the environment, we will definitely need to manage it. If not, there's a lot of organizations where we go to, we ask them how many certificates you have. Like, then they will say, oh, 10, 20 or whatever. Then when we do a discovery session, we realize that they have hundreds of certificates. Like, it's very common because there is a lot of unaccounted for certificates within an organization. Once you spin up a service, there is a good chance that by default it comes with a SSL, and the SSL usually is a self-signed and is unmanaged. So self-signed certificates are certificates that are not issued by a trusted third party, when we go back to the chain of trust, a self-signed certificate issues itself. So like I tell people that I'm Eugene and you're just supposed to trust me. Okay, so that is the definition of self-signed certificate. I think with that, I think I also run out of time. Sorry, this is a topic that I'm very passionate about because it's cryptography and SSL, so I took a little bit more time. I think that's all I have today.